I helped the startup go from manual chaos to fully automated AWS infrastructure within minutes, saving hours of effort and hundreds of dollars in cost. And I did this using Terraform. They were doing everything manually, from launching EC2 instances to configuring VPCs and security groups. Every deployment felt like a fire drill. I introduced Terraform, and it allowed us to codify everything from network layer to the compute into reusable, auditable, and version controlled templates. And I'm going to show you how I did it. Don't go anywhere. So you can see I have my code editor opened with my main.tf file. The main.tf file is where you write all of your Terraform configurations. So when you run your commands, it picks up the instructions from this file. And we're going to get started right away. The first thing we're going to do is we're going to grab our Terraform and required providers block. So this is where we specify the kind of plugin that we need. In this case, it's AWS, and the source is this is actually a shorthand. Right, there's a longer version of this, but this is more convenient. And then we specify the version that we want to use, which is going to be 5.0 upwards. Right. The next thing we're going to do is we're going to configure the AWS provider. So I'm going to add a comment. Let's say configure the AWS provider. Right, and then going to have the provider block. And what this block does is that it helps us to kind of tell Terraform some of the basic configurations that we want to use for Terraform. So in this case, we're specifying our region as US East 1A. And with that out of the way, we're going to start creating our VPC. So we're going to have a comment that says create VPC, and I'm going to call my own VPC cluster. So I'm going to create cluster VPC. Then I'm going to get the resource block for the VPC. Remember, what we're doing is an entire cloud setup. So we're going to start all the way from the network layer, and we're going to build up until we get to the server layer or the compute layer. So I have my AWS VPC resource block. I'm naming it cluster VPC because that's what I want the name of my VPC to be. And then we're going to put in the arguments here. The first one is the CIDR block. And specify I want my CIDR block to be 10.0.0.0/16. The next thing is going to be I'm just going to grab some other arguments from my second screen and put that in here. So we have enable DNS support and enable DNS hostnames, both of which are set to true. And then finally for this, we're going to add tags. Right, so what do we use the tags for? These tags, these are what we use to name the resources when they eventually get created. So when we're done with all of this and then we run it, you're going to see that the names that we give it within the tags are what is going to be displayed on AWS. Right, so I'm going to give it a key called name, and the value is going to be cluster VPC. And then, so we've created our VPC. The next thing we want to do is create a subnet. So for simplicity, we're just going to have one subnet, but within an ideal environment, you would have multiple subnets. So I'm going to say create a public subnet. We want to have a resource block, and it is going to be AWS _subnet. And then the name is going to be cluster public subnet. And the first thing we're going to do is we're going to specify the VPC ID, and that's going to be AWS. Also, we're going to reference the ID of this VPC we just created. I'm just going to select that. I'm going to go for the ID argument, or the ID property rather, not argument. Then we're going to set the CIDR block, and I'm going to just name this 10.0.0.0/24. Right, so this is 256 IPs. Right, if you're lost about CIDR blocks and all of that, that is more about networking. I can discuss about that later. For now, we're just going to stick to getting all of this set up. So we're going to have some more arguments and our availability zone. So we want this subnet to use the US East 1A availability zone. And then finally, we're going to give it a tag. So the key of name and the value is going to be cluster public subnet. So as a rule of thumb, I usually like to have my resources with similar names. So the VPC will be cluster VPC, the subnet will be cluster public subnet. If it were a private subnet, it will be cluster private subnet. That way, when you're trying to troubleshoot and things like that, it is easier to figure out or to know which resource belongs to which. All right, so keep that in mind. So the next thing we're going to be doing is creating the internet gateway. So we get the resource block, and it's going to be AWS _ internet gateway, and we're going to call it cluster IGW, which stands for internet gateway. Alright, so we're going to get our VPC ID again. So that's going to be this, and we're just going to wrap that up, give it a tag with a name called cluster, I think IGW. So notice how I give I make sure that the names are similar to the names of the resource block, because this is what is displayed in AWS, right? And this is what we use to reference our resource blocks within Terraform. So if you notice, when I created the AWS VPC, the resource block, the name of the resource or the type of the resource block is AWS _ VPC. You can see it's from HashiCorp AWS, right? Resource type, and then the reference name for this resource block is cluster _ VPC. So when I want to reference this in another resource block, I'm going to call for AWS _ VPC dot cluster VPC, cluster _ VPC, not hyphen, because this is the name we're going to use to reference this resource block in other resource blocks. Right? So the next thing we're going to do is create a route table. So type out resource block, and the type of resource block is AWS _route _table. The reference name is going to be cluster _RTB. So we're going to reference our subnet, that's this, a subnet ID, and we're going to create a route. So that doesn't have an equals to, so we're going to specify the CIDR block, and it's going to be 0.0.0.0/0, because we're trying to make this subnet a public subnet, right? And to do that, we need to have an internet gateway and a route table, and then make sure that they're all connected. So every route that belongs to this CIDR block, right, is sent to the internet gateway. Then we're going to associate this subnet with this route table, right? So all of this you would be familiar with if you have worked with AWS a bit, right? So the gateway ID, this is where we're going to specify the internet gateway. And don't worry if any of this looks a little confusing. Just try to make sure that you follow along, and then you understand the process, how we're going from one point to another. So we're going to give this a name, and it's going to be cluster RTB. Right. Then, like I mentioned, the next thing we're going to do is associate routes table with public with subnet. So we're going to resource, and that is the resource type is AWS route table association, and we're going to give it a reference name of cluster RTB assoc. Then we specify the subnet ID, that is the subnet that we want to associate with this route table. So that's going to be AWS subnet dot cluster public subnet dot ID, and the route table that we're going to be using is this. So this covers the setup of the subnet of the VPC. Right, so now we're going to move on to the compute layer, which is where we're going to talk about security groups, ingress and egress rules, setting up the EC2 instance, and things like that. So let's continue with that. So let me just leave a comment here. Compute layer begins here. The next one is going to be create a security group. And this part is usually confusing for most people, but I'm going to do my best to make sure that you get that. So the resource type we're going to be using is AWS _ security group. I'm going to call it cluster SG. Right. And we're going to specify our VPC ID. So it's going to be cluster VPC ID, and we're going to give it a tag. So we're going to also call this cluster SG, and then we move on to the next one. So the next thing we're going to be doing is, after creating the security group, we're going to be creating our ingress rule. And so ingress speaks about traffic coming in, egress speaks about traffic going out. So we're going to do both. So the resource type is going to be this AWS VPC security group ingress rule, and we're going to call it just call this one SSH ingress, because the only rule that we want to create is an SSH rule. So the first thing we do is we're going to specify our security group ID. So I'm going to grab that, and it's going to be this one. So .id, and the next argument is from ports, and that is going to be 22. Two ports is also going to be 22. So the way this AWS VPC security group ingress rule works is that it allows you to specify a range that you want to allow, right? So if you wanted to specify a single rule like we're doing here, the from and the to port would be the same, right? So and the default port for SSH is 22. That is why we have from port as 22 and to port as 22. Then we're going to specify the IP protocol. So what type of protocol is it? And that is going to be TCP. Then the CIDR IPv4. For simplicity, we're just going to leave it as anywhere. Right. So this is equivalent of anywhere IPv4 that you would see within the UI. Alright, so we're also going to create the egress rule now. Egress. The resource type is the only difference is going to be the egress. So it's going to be AWS VPC security group egress rule, and we're just going to call this all egress, again for simplicity, because by default in AWS the egress rule usually allows the entire range. And so we specify the security group ID, which is going to be this. Security group, this, and our from port is going to be 0. The to ports is also going to be 0. The IP protocol is going to be -1, and the CIDR IPv4 is going to be this, which is the same thing as this. So I'm just going to paste that here. Okay. The next thing we want to do is create the EC2 instances, or instance in this case, right? And the resource type is AWS_instance. So this one, and then we're going to call it just call it cluster instance. Right. So the first thing we can do is we can specify a count. This is actually optional, but when you have to create multiple instances, this can actually be very helpful. Right, so we're just going to leave that in there so you know that you can do that. Then we're going to get the AMI ID. Right, and you can actually get this from the AMI catalog within the AWS dashboard. The next is the instance type. We're going to change this to T2 micro, and remember that your instance, some of these configurations depend on the region that you are in. Right, so always make sure to confirm that. The next thing is our subnet ID. Let me space this out a bit. So the white space before your equals to doesn't really matter that much, to be honest, right? It's just to make it look as organized as possible. So our subnet ID is going to be this. We want to specify which subnet we are launching this instance in. So we're going to be referencing the cluster public subnet. Then the next thing is we're going to reference our security groups ID, and this is a list, so you need to make sure you have the square brackets set first. And we're going to say AWS security group ID. Then we want a public IP address, so we're going to set that to true. And the last thing we want to specify is a key name. So we haven't created our SSH key yet, so I'm going to comment this out for now. So we're actually going to do that next, right? So whenever you want to create an SSH key within Terraform, this is how you do it. So the first, let me add a comment. So create SSH key pair. The resource type is TLS private key. There are others, and we're just going to give it a name, a reference name of PK. The algorithm is going to be RSA. The RSA bits are going to be, so this is how long the key is going to be, right? And how many bits rather it's going to be. And the next resource block is going to be the AWS key pair resource block, and we're going to call this cluster key. So the key name, we're going to specify the key name, and we're going to call it cluster key pair. The public key, we're going to reference this, so TLS private key dot pk dot public key open SSH. Right, so then finally, because we want to have the file stored locally, so we're going to have a local file resource block, and we're going to call this local cluster key. So the content is going to be TLS private key, TLS underscore private key dot pk dot private key underscore pen. And we're going to specify the file name. So this is where we want the file itself to be stored. So I'm going to say store it inside this working directory with the name cluster key pair.pen. And then we're going to set the file permissions to 0400. So this is read only permissions, which is the secure or the right permission that every private key file should have. So now that we've done this, we can now come back here and comment this and specify our private our AWS key that we have created here. So you would see that we specify the key first, and then we now have the resource block for the key later. That's because Terraform doesn't follow a procedural approach, and Terraform is a declarative language, meaning that you can actually specify, you can reference a resource before you've even created it, right? And you won't get any syntax errors, unlike most programming languages like Python and things like that, right? So to finish the AWS instance resource, we're going to have a root block device for storage and an EBS block device as well. Right, so just make sure this is so we're also going to have an EBS block store block device, and to wrap this up, we're going to add our tag for this instance. So we give it a name called cluster instance, and with that we are done. So we're just going to run our Terraform commands now. Let me open this up so you can notice some of the changes that are going to take place. So the first thing we're going to run is Terraform plan. The first thing we're going to run is Terraform init. So we want to initialize the provider plugins that we actually specified at the top of this file, right? So the required providers, you can see that some new files are being added. Some new files are being added in there. So let's just give it a moment. Cool. Terraform has been successfully initialized. I'm going to clear my screen and then I'm going to run Terraform plan. So the Terraform plan command gives you a detailed output specifying what you are going to create, and it is always advised that you go through this output in detail so that you're not making a mistake somewhere without knowing. But because I have gone through this before, I am just going to go ahead and clear my screen. I'm going to run Terraform apply. So what this Terraform apply command is going to do is that it's going to take all of these configurations and it's going to actually create what we've asked it to create. So you have a question at the bottom saying, do you want to perform these actions? And the only value that you can supply to approve is yes. So I'm going to type yes and hit enter. And then you can see our resources are now being created. And you would notice now that in the file explorer, we have the cluster key pair.pen file that we created at the bottom. Right, so Terraform is intelligent enough to know which resource to create first and which one to create last, irrespective of how you structure your file. Right, so the cluster key actually created first. Now you can see that here. So let's wait for this to finish up. Okay, so we can see that the Terraform apply command has run successfully. We have a green success message saying apply complete, resources 12 added, 0 changed, and 0 destroyed. So what this means is that we've created 12 resources from scratch, right? 0 have been changed and 0 have been destroyed. This goes to show that Terraform can actually monitor a change in state in different resources. So if, for instance, maybe I came here and I changed this AMI, or I changed the count or something like that, right? Terraform would note that as a change and not a fresh creation, right? So now that that is done, let's let's go into our browser and confirm what we have done. Let's confirm if the changes have been actually made. And so we're here in the browser, and we're going to go into EC2. I'm logged into my AWS console, and I'm going to go into EC2, into my instances, and I can see that this instance was just created in US East 1A, so with the instance type of T2 micro. So I'm going to select this so that we can see more details. We can see we have a public IP address, a private IP address. You can see the instance type, the VPC ID. So the VPC is cluster VPC, meaning that the cluster VPC was actually created as well as the subnet. So let's go there. Let's also check that out. So we can see that our VPC was created. The subnet was also created, the routes table, the internet gateway. So we can actually see that everything that we specified within Terraform was created for us, right? This is actually the power of Terraform. You can use it for so many different things, not just AWS. You can use it across various cloud platforms for various purposes. This was actually a very simple setup. This was a very simple one. You can do more complex things with Terraform. Right? Now that we've confirmed that our Terraform resources have been created in AWS, I'm going to show you how to also clean up your resources in case you are doing this for learning purposes. So I'm going to clear my terminal, and I'm just going to run a simple command, terraform destroy. So what this is going to do is that it's going to get all of the resources specified within the file, checking the state. That's why you can see it saying refreshing state. And then when it's gotten the details of everything, it's going to ask, do you really want to destroy all resources? And I'm going to type yes. And in a moment, it's going to destroy all of the resources for you. Make sure you clean up all your resources if you are using all of this for learning purposes. And just like that, we have a fully functional VPC and EC2 instance running within the cloud, repeatable and version controlled. In the next one, I'm going to be showing you how to set all of this up with a CI/CD pipeline so your infrastructure builds itself. Subscribe and make sure that you hit the like button. Bye.